Can you solve a Zener regulator circuit in 60 seconds? No. That's exactly why you are leaving 4 marks on the table. So this question is on JEE Mains every year, yet most students freeze when they see it. So here's the cheat code. 3 steps, works every time, no memorization, will drill the top 5 probable questions. So when you see this on the exam day, it's muscle memory, free marks are waiting, so let's grab them. So first let us see why Zener diodes are being used and what are the characteristics. So it's a special purpose diode which is being used as a voltage regulator. Suppose you want to operate an electronic device at a particular potential difference, then you can connect a Zener diode in parallel, and Zener diode will maintain a constant potential difference. It's a highly doped semiconductor device, and in Zener diode the depletion region will be very thin, due to which the electric field will be very strong at the depletion region, and this field will play a crucial role in the breakdown region, which I'll discuss in the next slide. And it is always being used in the reverse biased mode. So I am hoping all of you know what is forward biasing and reverse biasing is. If you don't know, please write in the comment section and let me know, then I'll make a video on diode as well. Now let us see the typical voltage regulator circuit where we use Zener diode. So this is the unregulated input voltage. We'll apply the input voltage between these two terminals. Ri is the input resistance, RL is the load resistance, and this device is a Zener diode. Now it is similar to the normal diode except these two slant lines. Do remember the symbol. And I is the input current, IL is the load current, and IZ is the Zener current. And if we apply junction law at this junction, we can say I is equals to IL plus IZ. So we'll discuss this circuit in more detail after understanding the IV characteristic of Zener diode. So this is a typical diode characteristic. So on the x-axis we have voltage, on the y-axis we have current. So this is forward biasing, this is reverse biasing. So as we increase the forward biasing voltage, the current increases and the current will be of the order of milliampere. And in the reverse biasing, as we increase the voltage, it acquires a nearly constant current which is of the order of microampere, and this constant current is known as reverse saturation current. And it is due to the diffusion of minority charge carriers. And as we further increase the reverse biasing voltage, interesting phenomena happens at VB, which is known as the breakdown voltage. So let us see the definition is the reverse voltage at which the Zener diode begins to conduct current in the reverse direction. Begins to conduct means the current will be of the order of milliampere, and it is called Zener voltage. We can also call it Zener voltage or Zener breakdown voltage. Right. Now the I minimum is the minimum Zener current, and this current will be provided in the data sheet by the manufacturers. So it is the smallest amount of current needed to keep the Zener diode in the breakdown region. And then we have maximum Zener current, and this we can find by using the power rating of the diode which is given in the data sheet. So power rating will be given in the question, and from power you can find the maximum Zener current. So we can say I max is nothing but power divided by Zener voltage. So Vz is the Zener voltage. Now we have fair good idea about the characteristics and the IV characteristics. So let us now discuss the voltage regulator circuit in detail. So whatever question you will come across in JEE Mains, all questions will be based on this diagram. So you will be given the Zener voltage. So across the Zener diode we have Vz. Vz is the Zener voltage. Since load is connected in parallel, we will get the same potential difference across the load. So from this we can find the load current. So first step would be finding the load current. So IL will be Vz over RL. So once we know IL, the second step would be finding the input current. How we can find? Suppose the input voltage is Vi, and we know the load, we know the potential difference across the Zener. So across Ri will be having Vi minus Vz. It will be the difference of input voltage and the Zener voltage. So now we know the potential difference across input resistance. So this will give us the input current, which will be Vi minus Vz over Ri. Now we know I, now we know IL. So from this we can find Zener current. So this is the 3-step process which you have to follow in every problem. Now I am going to discuss 5 PYQs based on different concepts. So and you will get question from these 5 concepts only. So let us see the very first question. Figure shows a DC voltage regulator circuit with a Zener diode of breakdown voltage 6 volt. So Zener voltage is given. So this is 6 volt. If the unregulated input voltage varies from 10 volt to 16 volt. So input voltage is varying 10 volt to 16 volt. Then what is the maximum Zener current? Okay, right. So the first step would be finding the load current. So we know the potential difference across the load resistance. It is 6 volt, which is same as the Zener voltage. So IL will be 6 divided by the load resistance, which is 4 kilo, which comes out to be 1.5 milliampere. So we got the load current. Now the second step would be finding the input resistance. Now input resistance will depend upon what input voltage we are taking. So let me take this as VI only. So I will be VI minus Zener voltage, which is 6, divided by the input resistance, which is 2 kilo. Now if I want to find the Zener current, so that will be I minus IL. So Zener current will be VI minus 6 divided by 2 kilo plus minus 1.5 milliampere. Now we want to maximize the Zener current. So Zener current will be maximum when the input voltage is maximum. So IZ max will be, so in maximum value of input current is 16. So 16 minus 6 divided by 2 kilo minus 1.5. So that will be 5 milli minus 1.5 milli. So this comes out to be 3.5 milliampere. Right. So this is the first type of the problem which can be asked in JEE Mains. Now let us see the second question. The circuit shown below is working as a 8 volt DC regulated voltage source. When 12 volt is used as input, the power dissipated in each diode is. So there are 2 diodes which are connected in series and the input voltage is 12 volt. And across these 2 diodes we have given potential difference of 8 volts. So we are not connecting any load in parallel to the diode, only these 2 diodes are there, right? So what we can say, whatever will be the input current, so that current will pass through the diodes. So in this case I is nothing but the Zener current. So we can say across each diode the potential drop will be 4 volt. By symmetry we can say, right, since they are connected in series, so 4 volt. So can we say across these 2 resistors the potential drop will be 12 minus 8. So that will be 12 minus 8. Now we know the potential drop across the input resistors, which is 200 plus 200, 400. So the input current will be 12 minus 8 divided by 200 plus 200. So this comes out to be 4 over 400, or we can write this as 10 milliampere. Now we know the input current, and this is also the Zener current, and we want to find the power dissipated in each resistor. So we know the potential drop across the diode. If you multiply that with the current, we'll get the power. So power will be IZ times 4 volts. So that will be 10 times 4 milliwatt. So that will be 40 milliwatt. So 40 is the answer of this question. Now let's see the next type. In the given circuit, if the power rating of Zener diode is 10 milliwatt. Now they have given the power rating, and I told you by using power rating we can find the maximum Zener current. The value of series resistance Rs to regulate the input unregulated supply is, so we have given 8 volt as a input voltage. So from this we can say the input resistance, input current, so input voltage, or you can say voltage across Rs will be 8 minus 5, which will be 3 volts, and we can say the input current I will be given as 3 over Rs. right? So the input current will depends upon the value of Rs, and we have given power rating. So first let us find the maximum Zener current. So I max will be power over Zener voltage, which is 5 volt. So that comes out to be 2 milliampere, right? So the maximum current, Zener current is 2 milliampere, and across this load the voltage will be 5 volt. So we can find the load current, which is fixed, right? It will be 5 over 1 kilo, that will be 5 milliampere, and we have to find the value of Rs. So we can say, by applying junction law at this junction, I is equals to Iz plus IL, which is 3 by Rs, equals to Iz plus IL will be 5 milli. So we want to suppose now so in this particular case we know the maximum Zener current. So if minimum Zener current is not given in the question, you can assume it to be 0, right? So here you can assume Iz minimum is 0. So we can find the range of Rs which is applicable, right? So in this question 3, or we can say Rs over 3 will be 1 over 5 milli plus Iz. Now if the denominator is maximum, then Rs will be minimum. So Rs minimum will be 3 divided by 5 milli when and Iz maximum, right? That is 2 milli. So this comes out to be 3000 over 7. Okay, so the minimum value of Rs will be 3000 or 3 by 7 kilo ohms. Now if I want to find the maximum value, in that case we'll take Zener current to be 0. So this comes out to be 3 by 5 kilo ohms. So Rs value should vary from 3 by 7 kilo ohms to 3 by 5 kilo ohms. Okay, so we have a range. Sometimes they'll ask you what is the minimum resistance and the maximum resistance of Rs, but in this question they have clearly mentioned what is Rs, right? So none of these options is correct. So option 4 should be the right answer. Now let us see another type. A Zener of breakdown voltage 8 volt and maximum Zener current is 10 milliampere. So maximum Zener current is given and is subjected to an input voltage of 10 volt. So here 8, so across the input resistance will be having 10 minus 8, that will be 2 volts, and this will give us the input current. And in the given circuit, RL represents the variable load resistance, the ratio of maximum and the minimum value of RL. So we have to find RL range, basically the minimum and the maximum value, right? Again in this question minimum Zener current is not given, so you'll assume it is 0. So Iz minimum will be 0, right? So let us write down the load current. So across this the voltage will be 8 volt, so load current will be 8 over RL, and input current will be 2 over 100, so that comes out to be 20 milliampere. So we got the input current, we know the load current, and Zener current can vary from 0 to 10 milliampere. So I is equals to Iz plus IL. So 8 by RL will be equals to 20 milli minus Iz, or we can say RL will be 8 over 20 milli minus Iz. So if I want to find the maximum value of RL, denominator should be minimum, and it will be minimum when Iz is maximum, right? So RL minimum will be 8 over 20 milli minus 10 milli. So that comes out to be 8. Okay, sorry, it should be 0, no? For minimum value, Iz should be 0. So this comes out to be 400 ohms. Now if I want to find the maximum value of RL, so in that case Iz will be, so we'll have to take the maximum value of Iz. So this will be 80 over 20 milli minus 10 milli. So that comes out to be 8 over 10 milli, which is nothing but 800 ohms. Right, so now we have to find the ratio of maximum and minimum. So it comes out to be 2. So 2 is the answer of this question. Now let's see this question. A 8 volt Zener diode along with a series resistance R is connected across a 20 volt supply. If the maximum Zener current is 20 milliampere, the minimum value of R. So we have to find the minimum value of R. And I max is given 25 milliampere. And Zener voltage is given as 8 volts. So across the input resistor the voltage will be 20 minus 8, that will be 12 volts. And this is the input current. So input current can be written as 12 over R. And maximum Zener current is given. And RL, nothing is given about RL. So whenever you get such kind of a question where load resistance is not given, right? And we have to find the minimum value. Okay, let me write down. So this is 8 volt and this is IL. So IL can be written as 8 over RL. So let us write down the junction law equation. So I is equals to IL plus IZ. So that will be 12 over R, and IL can be written as 8 over RL plus IZ. It can vary from say 0 to 25 milliampere, right? And we have to find the minimum value. So obviously the minimum value of R, okay, let me write down. So R by 12 can be written as 1 over 8 over RL plus IZ. So IZ, yes. So we will get a maximum. So if I want to minimize R, we have to maximize IZ. So we can say R will be 12 over 8 by RL plus IZ will be 25 milli. And if I go through the answer key, the answer is given as, so R is given as 12 over 25 milli, which comes out to be 480 ohms. So basically they have assumed this RL is quite large, it is tending to infinity. So if RL tends to infinity, then a capital R will become 480, right? So this assumption they have taken in the solution. So I hope the concept is clear. If you like this video, you will also like PregB's 3-step success system for last mile journey for JEE and NEET preparation. The truly unique way to refine your preparation and maximize your score. So the first step would be the deep dive. A senior faculty assess your specific weak areas and builds a 100% customized master plan just for you. No more generic studying. Now the second step would be one-on-one concept mastery. So get a dedicated online classes focused only on the topics where you struggle. Learn exactly how to apply those tricky concepts and solve problems effectively. Now the third step would be track and triumph. See your progress instantly. A custom test series which comprises of chapter test, part test, full syllabus test shows you where you stand and how fast you are climbing the ranks. So maximize your score in this final journey. Click now to book your personalized session and start your path to success.